Alright friends, welcome back. In this video I'd like to go ahead and move on with section 1.4 and take a second day for this because in this video we're going to go ahead and take a look at some methods for solving quadratic equations that are maybe a little bit more sophisticated than the ones from the previous video. So in this video specifically we're going to go ahead and talk about methods for solving quadratics that include completing the square and also quadratic formula. So let's get started with that. Okay, so when you complete the square, what that means is that you're going to take what you are currently given and check to see if this is going to match one of those perfect square trinomials. So back when we were talking about chapter P, we had a formula for perfect square trinomials that went a little bit something like this. It went any trinomial that's of the form u squared plus 2 times u times v plus v squared. Okay, if we have one of these, then we figured out that we could go ahead and factor it in this way. We could say u plus v squared. Okay, so let's just see if we have something that matches up to that, right? So I think playing the role of u would be x there because that's what's sitting in u's seat. But when we try to figure out what's playing the role of v, v squared is sitting in the number 2's seat. And the thing about that is that that would be the square root of 2, and that wouldn't be very nice. Plus, we wouldn't match up with the middle term here in the perfect square trinomial formula. So unfortunately, what we are currently given here is not a perfect square trinomial. And so what we're going to do is we're going to turn this into a perfect square trinomial. And the way that we're going to do that is we are going to first take the constant term over to the other side because that's kind of what's creating the issue here. And that's going to, of course, leave us with x squared plus 4x. And I'm going to leave a little bit of a space here. And on the right-hand side, I'm going to evaluate 0 minus 2. And, of course, that's going to be negative 2. Okay? So here in this blank space right here, what I'm going to do is I'm going to introduce a term to the left-hand side that's going to turn it into a perfect square trinomial. And because your u, playing the role of u, we said was x earlier. What I'm going to do is I'm going to look at this middle term, and I'm going to match it up to the middle term of your perfect square trinomial, and I'm going to see what would have to play the role of v so I get one of those perfect square trinomials going on. And so, just to make the process go a little bit quicker here, the way that we're going to go ahead and think about that is we're going to take whatever number is playing the role of b, and for us here that is going to be the number positive 4. We're going to take a look at that b number, we're going to divide it by 2 first, and then we're going to take whatever results from that and square it. Okay? And so this is a process here that oftentimes I refer to in my classes as half and square. All right? And so that is going to be the step that makes completing the square work, because if I take 4 divided by 2, I get 2. If I square that result, 2, I get a positive 4. So that's why I'm going to go ahead and go through and introduce a plus 4 to both sides of my equation. Okay, so the plus 4 on the left-hand side, because that's going to make this into a perfect square trinomial, and I can go ahead and factor this into x plus 2 quantity squared. And on the right-hand side, just adding the 4 because I added it to the left-hand side. Whatever you do to one side, you have to do to the other side. But we can evaluate that right-hand side. That's negative 2 plus 4. That's going to make positive 2. Okay, now why does that help? Well, because what we had was an expression or an equation where x showed up in 2 different places. Makes it pretty hard to isolate, especially because those 2 different places are not like terms that we can combine. But now we've taken it and factored it so that x only shows up in one place, and that means that we can go through and do what we did in the last video, which is to use our inverse operations to get x isolated here. So that's exactly what we're about to do. We're going to undo an exponent of 2, of course, by taking a plus or minus square root of both sides of this equation, and that is going to leave us with x plus 2 on the right-hand side, the left-hand side. On the right-hand side, the square root of 2 turns out to be an irrational number. It's a long, ugly decimal that never ends or has a repeatable pattern, so the nicest way to write it would just be to go ahead and write it the way that we initially had it, the plus or minus the square root of 2. And then, of course, to get x isolated, one last step, we would simply subtract 2 from both sides, in which case, remember how we would write this according to the last video. We said, since we subtracted 2, I'm going to go ahead and continue to write a negative 2 here, and then plus or minus the square root of 2. And what this is, remember, this is 2 different answers that I'm writing with some shorthand notation because of that plus or minus. Remember that this is one answer is with the plus, that would be negative 2 plus the square root of 2, and the other answer here would be with the minus, and of course that would be negative 2 minus the square root of 2. So I really do end up with 2 different answers here, and if I was really curious about what the decimal approximations were, I could go ahead and plug those in the calculator and solve. In this next example here, again, we have something that doesn't quite look like what we want it to look like. So what we're going to go ahead and do is create a little bit of space here. So x squared minus 3x, leave a little bit of space, and that is equal to 7, okay? And so again, our goal is we're going to try to take a look at this left-hand side and see if we can do something to introduce a term there that's going to turn this into a perfect square trinomial, because if we do, we know that this can factor into u minus v squared on the left-hand side. And so remember how this is done, right? We would take that b term, we would divide it by 2, and then we would square the result. Well, negative 3 is not really a number that you can divide by 2 very nicely because it's an odd number. So negative 3 over 2 would have to be the best we could do there. But if we square that, we square the negative 3 on top to get positive 9. We square the 2 on bottom to get positive 4. Okay, so that is the term that we're going to have to introduce to both sides of this equation in order to complete the square. So plus 9 over 4 plus 9 over 4. Okay, that's going to make it so that on the left-hand side, what I end up with is x minus 3 over 2. Again, that's just me playing that whole game of what's playing the role of u, what's playing the role of v, okay? And then on the right-hand side, I end up with 7 plus 9 over 4. That would be something that I'd have to go ahead and combine into a single fraction. And if I find a common denominator there, maybe putting 7 over 1, that would end up giving me 37 over 4. Okay, and so again, this is valuable because now I have x in one location, and I can go ahead and do my inverse operations to solve for x. So taking a plus or minus square root of both sides, the left-hand side becomes x minus 3 halves is equal to plus or minus the square root of 37 over 4. Now, the square root of 37 is not something that can break up very nicely, but the square root of 4 is simply just 2. So I'm just going to go ahead and write it as 2, and then finally the last step there would be to go ahead and add your 3 halves to both sides. And we would end up with this final result right here. So x by itself is equal to, since I added 3 halves to both sides, I'm going to go ahead and say that that's positive 3 halves, and then plus or minus the square root of 37 over 2. In this next example here, one of the things that we need to make sure that we do whenever we complete the square is we need to make sure that we have the form of x squared plus bx on the left-hand side. And the special thing about this form is that playing the role of the number in front of x squared is simply just a 1, and then on your bx term, it's going to be nice and easy for us if this is a number that turns out to be even because of the whole halve and square step. If it's even, we can divide it by 2 very nicely. Okay, well, if you look at our example, we don't quite have that form going on because the number sitting in front of x squared, of course, is a 3 and not a positive 1. So in order to go ahead and handle this, what we might do on the left-hand side is we might factor out a 3 from everything that's on the left. If I do that, then I'm going to go ahead and write 3 times the leftovers equals 0. And of course, what is that going to look like? That's going to look like x squared plus 2x. And again, you'll notice that I left a little bit of space there because now we're going to go ahead and do that whole completing the square step of taking our, look at the number b and cutting it in half and then squaring the result. So halve and square. So 2 divided by 2, that results in a positive 1. If I square that result, I end up here with plus 1. Okay, or positive 1. So that's why I'm going to go ahead and introduce a plus 1 in the parentheses there. But one thing to be a little bit careful about is that you did just write plus 1 there, but you wrote plus 1 inside of this group right here in the parentheses that's all being multiplied times 3. So what we really introduced to this side was whatever 3 times 1 is going to be, and of course that is going to be positive 3. Okay, so that's just a little bit of a nuance in that problem since we introduced that number to introduce the perfect square trinomial form, which of course again looks like u squared plus 2uv plus v squared. We're going to have to be a little bit careful about what we really added to the left-hand side. It would be 3 times 1, okay? And so, of course, if we have that form now going on, this would factor into u plus v all squared. And so I can go ahead and rewrite the left-hand side as the 3 that I factored out times, it looks like that's going to be x plus 1 squared. And then on the right-hand side, I simply have 0 plus 3, and that's going to make 3. And now again, x is in one place, which means I can now start to do my inverse operations to get it isolated. So I'm just going to go ahead and do the usual steps here by first dividing both sides by 3. On the right-hand side, I ended up with a 1. And then I'm going to go ahead and get rid of that exponent of 2 by taking a plus or minus square root of both sides. I end up with x plus 1 there on the left. And on the right-hand side, I have the square root of 1. That's actually something that you can evaluate. That's just going to end up being positive 1. So plus or minus positive 1. Okay, and then of course to get x by itself I'd have to go ahead and subtract 1 from both sides, in which case I end up with x is equal to, since I subtracted 1 from both sides, I'll say negative 1 and then plus or minus 1. Now, the reason that we boxed the answer in this case in the previous examples is because what we ended up with were the square root numbers, and these are actually ones that we cannot perform the plus or minus very nicely for. But here, since we're dealing with these nice integers, we actually can perform these operations. So let's go ahead and do the one with the plus and then do the one with the minus. So I would have -1 plus 1 and then -1 minus 1. And these are things you can actually figure out and evaluate. So -1 plus 1, that of course is 0. -2 minus, or sorry, -1 minus 1 is -2. There we go. Okay, so we have these two answers for that quadratic equation, okay? So whenever you complete the square, that's something you're going to have to make sure that you do, all right? Moving on here to this next one, I've already done a little bit of work to try to rewrite this in the form that we prefer, because remember, we're looking out for this form right here up top. We're looking out for that 1x squared plus bx, and I'm close to that, but you'll notice that the number that's sitting in front of x squared is actually a -1, and what we can do to get rid of that is we can just go ahead and employ that exact same trick that we did in the last example, where I factor out something so that the number sitting in front of x squared is just simply a +1, just like that, okay? And so I'm going to go ahead and rewrite this as x squared minus 4 in the parentheses, and then -5 on the right-hand side. So again, now that I have this going on, I can go ahead and figure out what half of my b squared is. So this is the half and square step, right? You're going to take your b number, you're going to divide it by 2, and square the result. So -4 divided by 2 is -2, square the result, you get a +4. Okay, so that is exactly what I'm going to introduce there. But remember that this was inside a group that was all being multiplied times -1, so what we should really be introducing to the other side of this equation is not +1, it should be, or sorry, not +4, it should be -4. Okay, so let's go ahead and introduce that over here. We could have also written that as a plus -4, but remember, plus negative turns in the operation into a subtraction, and so we're going to go ahead and have that, okay? I'm going to go ahead and erase my previous answer here just to save room for the one that I'm currently doing, okay? And now let's go ahead and figure this out. Now that I have something that looks like a perfect square trinomial, now I have something that looks like u squared minus 2uv plus v squared, and I know that that will factor into u minus v squared, and so I'm going to go ahead and apply that here. So we have the negative that was out front, but now I have x minus 2 as the factorization. X minus 2 squared, I should say, okay? And then I also have -5 minus 4, and that's going to, of course, give me -9. And you notice that I've got this extra copy of a negative on both sides. So if you think with me here, if we were to divide both sides by -1, then that would simply give us the quantity x minus 2 squared is equal to 9. And now we could go ahead and evaluate, or not evaluate, but start to isolate x here. And of course, we would do that by first taking a plus or minus square root of both sides. And so that would give us x minus 2 by itself is equal to plus or minus the square root of 9, which of course here would be make a 3, and then of course we would have a final result of x is equal to, if I were to add 2 to both sides here, so plus 2 plus 2. Since I added 2 to both sides, that would be a +2, and that would be plus or minus 3. And again, because we have some nice integers here, we could actually go ahead and do the arithmetic and figure out what these solutions are going to be. So that's going to be 2 plus 3 and 2 minus 3. So 2 plus 3, of course, makes 5. 2 minus 3, of course, makes -1, and those would represent your two solutions for this process here. Okay, so completing the square, just remember to rearrange until you get that form that you want, and then have and square to actually go ahead and execute. Okay, here in this next example, again, we don't have exactly what we would like here. We need to go ahead and bring that constant to the other side, so we'll do that first. So plus 8, and then on the left-hand side with whatever's left over, remember, we want this number in front of x squared to be a 1, so for that reason, I might go ahead and factor out a copy of 2. Okay, so that's going to leave behind x squared plus 2x, and then I'll leave a little bit of space, and that's equal to 0 plus 8, which of course is just 8. And then I'm going to go ahead and do the halve and square step. So playing the role of b is +2. If I cut that in half and then square it, I get a +2 here. But don't be hasty when we go ahead and add that to the other side, because remember, what we really introduced was whatever 2 times +1 is. Okay, so of course that's going to be +2. So I'm going to go ahead and add 2 to the other side here. Okay, I could rewrite the left-hand side as 2 times the quantity x plus 1 squared. That's just me following my factoring formula. And then here, 8 plus 2, of course, is going to give me 10. And then because x is in one place, I can go ahead and start to do my inverse operations to get it by itself. So on the right-hand side, I end up with 5. And then if I take a square root of both sides, plus or minus, on the left-hand side, I end up with x plus 1. On the right-hand side, I end up with plus or minus the square root of 5. And then if I bring that 1 over, -1, I'm going to end up here with x is equal to -1 plus or minus the square root of 5. Okay, very simply done. all right? So let's go ahead and move on to the next factoring formula, or not factoring, goodness, the next quadratic method for solving a quadratic here, and that's the quadratic formula, okay? Now, real quick before we get too knee-deep into this, we need to make sure that we have the green light to actually do quadratic formula, and that means that your equation needs to be written in this form before you start, and the reason for that is because, of course, we need to go through and make sure that we are able to pick out what is playing the role of A, what's playing the role of B, and what's playing the role of C. Because if you actually look at the quadratic formula, these are all things that you would need to plug in, okay? Also, one of the things about the quadratic formula is that part of it is under the square root, okay? So this expression under the square root is actually something that we give a name to because it lives under the square root. And remember that when we have a square root, we always have to make sure that we're not taking the square root of a negative number. And so this part under the square root is so important. It's the one that we have to make sure is not negative. We give that a name. We call that the discriminant. And, of course, what we do is we go ahead and calculate it, and we figure out if it is greater than 0, if it's equal to 0, or if it's less than 0. Remember that case where it's less than 0 is what we don't want, because that's going to mean that we don't have any real solutions in that case, because then we would be trying to divide by a negative number. All right? In the case where the discriminant is equal to 0, I want you to think about this real quick, right? So if the discriminant is equal to 0, then that means that this entire part under the square root becomes 0, or in other words, disappears. The square root of 0 is simply just 0, so this whole square root will disappear. And then the plus or minus, I have nothing to plus or minus here, so that's going to disappear here as well. And what that's going to mean is that I end up with the opposite sign of b over 2a if the whole discriminant turns out to be 0. And that's why we say in this case that you would only have one real solution. And as a matter of fact, we might as well just go ahead and make the note, your one real solution is going to be what you get whenever you take the opposite sign of b and divide it by 2a. Okay? Now, in the case where your discriminant calculates out to be something that is just simply greater than 0, then that would be a case where you end up with two real solutions, and that would be one of the things where we have to make sure that we are able to figure out what those two solutions are and box those two solutions at the end of our work here. So we're going to go ahead and take a look at a couple of examples here and use quadratic formula to go ahead and evaluate them. Now, again, in order to get the green light, we make sure that we have all the terms on one side, leaving 0 by itself on the other side. So if I go ahead and subtract 9 from both sides in this first example, then that would be something that looks like this: x squared minus, or sorry, not minus, plus 3x minus 9 is equal to 0. All right? It would be at this point that we would want to go ahead and identify what's playing the roles of A, B, and C. And so I think pretty straightforward here. Playing the role of A is 1, playing the role of B is 3, and playing the role of C is -9. Okay? One of the things that I always like to do first is to actually go through and calculate the discriminant, because that's going to give me some information about what I should expect to end up with here. Okay, so I'm going to go ahead and calculate that at this time. So b squared minus 4 times a times c. What is that going to be? Well, playing the role of b for us is 3, so that'll be 3 squared minus 4 times a, which is 1, times c, which is -9. Okay? And now that is going to be an expression that you can type in completely into the calculator if you like, and I'm just going to go ahead and do that in my calculator here really quickly. And we would end up here with positive 45 as our discriminant. Okay? So we know what our discriminant now, it's 45, so now I'm going to go ahead and use the quadratic formula to go ahead and figure out what the rest of my answer is here. Okay, so I'm just going to go ahead and follow the formula from up here. All right, so that's going to be x is equal to the opposite sign of b, which is exactly how I read the negative b here in the formula. If you're going to put a negative in front of a number, that's like you're changing the sign of the number. So that's how I read that, is the opposite sign of the number b. Okay? Playing the role of b for us was positive 3. I need to do the opposite sign of that, so that's going to be -3. And then I'm going to say plus or minus the square root of my discriminant, which remember we calculated to be 45. Okay? And then that is all over whatever 2 times a is. Playing the role of a for us, of course, is +1. And this would be something that I would like you to go ahead and take a look at and see if you can simplify it as much as possible, okay? Of course, the 2 times 1 in the denominator, that's just simply going to make a 2 for us. And then we have -3 plus or minus. But remember that back in Chapter P, we took a look at the square root numbers, and we took a look at how we can go ahead and write them in the simplest possible way, okay? Simplest radical form, all right? We would go ahead and take a look at 45. We would ask ourselves, what's the largest perfect square number that goes into 45? And if you go through that list, I believe the largest perfect square number is going to be 9, okay? That you could break up a 45 is 9 times 5, and because the square root of that 9 is 3, I would go ahead and rewrite the square root of 45 as 3 times the square root of 5. Okay, so again, if you guys need some more guidance over simplest radical form, then I would encourage you to go ahead and go back to Chapter P and see if you could find that video where we initially talked about that. But as far as simplifying this is concerned, I believe that's the best that we can do. None of the things on top are going to cancel or simplify with any of the terms that are on bottom, so those would represent the two solutions that we have there. In part B, same thing. It looks like this is already written in the form that we prefer, so just identify your A, B, and C. Playing the role of A is 2, playing the role of B is 1, and playing the role of C is -1. Okay, let's calculate that discriminant first. I'm going to do that up here. So B squared minus 4 times A times C. Playing the role of B, of course, is 1. And then we need to subtract off whatever 4 times A, which is 2, times C, which is -1 is, right? So, again, you could type that whole thing into the calculator all at once, and I'm just going to go ahead and do that now for the sake of speed. That's going to give us 9, okay? So your discriminant, again, is a positive number, and so what that's going to mean is we should expect to end up with 2 real solutions at the end of this process, okay? And so let's actually go ahead and do that. So x is equal to the opposite sign of b, which is going to be -1, plus or minus the square root of the discriminant, and here we calculated that to be 9. All right, that's all over 2 times a, which in this case is a 2, and we just need to go through and actually simplify this down. Now, the square root of 9 actually turns out to be a nice number. It turns out to be 3. So this is going to be -1 plus or minus 3 all over 2 times 2, which of course makes 4. And because what you ended up with here is just a bunch of integers and not square root numbers, this is going to be one of those things where we can actually figure out what our 2 solutions are going to be by doing the one with the plus and then doing the one with the minus. So let's go ahead and evaluate what -1 plus 3 all divided by 4 is, and then after that evaluate what -1 minus 3 all divided by 4 is. Okay? So if you do the one on top, that's -1 plus 3, that's going to make +2. And if we have the fraction 2 over 4, that of course is going to reduce down to a 1/2 for us. So that'll represent one of our solutions. Down below here we have -1 minus 3, that's going to give us -4, which if we were dividing that by 4, of course that's going to simplify down to -1. And so we did end up with 2 real number solutions because our discriminant, of course, again, was something that was greater than 0. Here in this next example, we are going to have to do a little bit of rearranging first, just so that we make sure we know what to type in. So the x squared term needs to come first, and because we were subtracting that, I'll go ahead and say minus x squared, and then plus 2x, and then plus 2, that is equal to 0. Okay, if we identify our numbers a, b, and c, playing the role of a is -1, playing the role of b is 2, and playing the role of c is also 2. Let's calculate that discriminant. So b squared minus 4 times a times c, that's going to be equal to, playing the role of b is 2, so I'll say 2 squared, minus 4 times a, which is -1, times c, which is 2. Okay, and again, I'm just going to go ahead and type that whole expression into my calculator and figure out what that discriminant is in one fell swoop. It looks like that's going to be +12. Okay, and so when I set up my quadratic formula here, x is going to be equal to the opposite sign of b, so that will be -2 in this case, plus or minus the square root of our discriminant, which we calculated to be 12, and this is all divided by 2 times a, which is 1. Okay, now, at this point, what I would like to do is go ahead and think about how the square root of 12 might be written in simplest radical form. Well, the largest perfect square that goes into 12, of course, is 4. And if you take the square root of 4, you get 2. So that's why I'm going to go ahead and write this as -2 plus or minus 2 times the square root of 3. Again, if you need some more guidance on writing in simplest radical form, then make sure to go ahead and find that Chapter P video. Okay? Now, what we have here is something that looks like this at this step, and what you'll notice is that I have a bunch of 2's on top and I have a 2 on bottom. That is going to mean that we're going to have some canceling going on here. And really what's going to happen behind the scenes here is that this big divided by 2 is really a common denominator. So I'm going to go ahead and split up both terms in my numerator as having their own copy of the common denominator here. And if I write it like that, then that might be something that you can recognize as the 2's would cancel here, and that would just leave us simply with -1. And then plus or minus, and then the 2's would cancel here, and that would just simply leave me with the square root of 3, okay? And that, I believe, would be the easiest way of thinking about how that would work out there for you. But we do end up with these 2 solutions there, and again, that works because, again, your discriminant turned out to be a positive number, so we should expect 2 real solutions there. And then as the last example I like to do in this video, we're going to have to do some rearranging here, maybe bringing this 8t over to the other side. And by the way, there's no real weird things that are going to happen because we're dealing with t. If you wanted to change these all to x's, you absolutely could. But we have 0 here is going to be equal to, and I'm going to go ahead and write this out on the right-hand side, 2t squared minus 8 times t, and then plus 5 because it was a +5 there, okay? Identifying our variables here, this is going to be a is going to be played by +2, b is going to be played by -8, and c is going to be played by +5. Okay, let's calculate that discriminant. So that would be something that we could do right here. B squared minus 4ac is equal to what? Well, playing the role of b is a -8. So just remember that whenever you square that, that's going to have to be something that you put in a set of parentheses because we need to signify that we're also squaring the negative there as well. Minus 4 times a, which is 2, times c, which is 5. And we can go ahead and plug this all into the calculator at once and get the result all at once here. And apparently that is going to be a positive 24. And so again, that means that we're going to end up with 2 real solutions at the end of this process. So I'm going to go ahead and start my quadratic formula up here. So x is equal to the opposite sign of b, which because b is negative 8, the opposite sign of that is going to be positive 8, plus or minus the square root of the discriminant, which we already calculated to be 24. All right, and that's all over 2 times a, which playing the role of a is 2. And so what we have here is something that we can go ahead and simplify down. All right. Now, the square root of 24, we need to think of the largest perfect square that goes into 24. I believe that's going to be 4. If we take the square root of that 4, we get 2. So that's why on the top, I'm going to go ahead and write this as 8 plus or minus 2 times the square root of whatever's left over there, which would be a 6. And this is all divided by 2 times 2, which of course makes 4. And I'm going to go ahead and simplify this in the exact same way as we did the last example, where I give both terms in the numerator their own copy of that common denominator, and then go ahead and cancel or simplify accordingly. Okay? Well, I see here 8 divided by 4, that's simply just going to make a 2. Plus or minus, and then the 2 on top is going to cancel with the 4 on bottom, just leaving us with 1 over 2, or in other words, just the square root of 6 over 2, and that is going to represent our final solution, or solutions for this quadratic equation. Okay, so I hope that this video has been of some help to you. So whether you're doing completing the square or quadratic formula, it's a little bit of a process in both methods, but I hope that what I've demonstrated here in this video has made some sense to you. If you guys have any questions whatsoever, as always, please feel free to get those answered. But that's all I have for this video. Thank you very much for your attention, and I'll speak to you in the next one.